Hi, welcome to this video series on GMAT preparation for your quantitative reasoning section. The quantitative reasoning section has two types of questions. One is the data sufficiency and other is the problem solving. So today we'll be looking at some problem solving questions on the topic of number properties. So let's begin. How many of the integers between 25 and 45 are even? Okay, so they are between 25 and 45. So what are the even numbers? They will start from 26 and go up to 44. The tedious way of doing it is writing it down, that is 26, then 28, then 30, then 32, then 34, 36, 38, 40, 42 and 44, and say that you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You have 10 integers between 26 and 44 both included, or else you can simply just subtract 26 from 44 and then divide it by 2. Why are we dividing by 2? We need we'll have one odd number for every two numbers that are there, one even number for every two numbers that we have, plus 1 since both of these are inclusive, 26 and 44. 44 minus 26 is nothing but 18 divided by 2 plus 1, which is 9 plus 1 equals to 10, which is answer is option D. So that's how you calculate without writing down all the options. Let's look at the next question now. This question says when positive integer k is divided by 6, the remainder is 3. Which of the following cannot be an even integer? So let's say that the positive integer k is divided by 6, that is 6 times x. It's a multiple of 6 times x plus 3. Now you divide this by 6, this gets easily divisible by 6, this is directly divisible by 6, and here is your remainder, that is 3, and x is some positive integer. So they are asking which of the following cannot be an even integer. So let's just check the options. So k plus 1 will be equals to 6x plus 3 plus 1, which is 6x plus 4. 6x is, since it's a even number, multiplied by any number will give you an even number. Even plus even will always give you even. So this is not your answer, this is not the option we're looking for. Sorry, k minus 11, which is equals to 6x plus 3 minus 11, which is again 6x minus 8. Again this is 6x is an even number, 8 is an even number, even minus even will again give you an even number. So this is also out. Let's see what option C says. 4k plus 2. This directly, even without substituting, you will say that this is an even number, because it is 4 is an even number multiplied by any number will give you an even number, plus 2 is an even number. So even plus even will give you even. So this 4k plus 2 is also not your answer. K minus 3 divided by 3 plus 2. So let's look at this. K minus 3 will be 6x plus 3 minus 3 will be 6x divided by 3 plus 2, which is equals to 2x plus 2. This is again 2 into any number will be an even number, plus an even number, that is 2 is always even. So this is even plus even, that is even. So this is also odd. So you can directly say that this will be in, this will be the answer that we are looking for, but let's just check. K by 3. K by 3 is what? 6x plus 3 divided by 3. This is equals to 2x plus 1. 2x plus 1. 2 into any number is an even number. Even plus 1, that is an odd number. Even plus odd will always give you an odd number. So this is your answer. Answer is option E. Let's look at the next question now. If n is an integer, which of the following must be even? If n is an integer, n can be even or odd. So you cannot definitely say whether n plus 1 will be even or odd. It will depend on what n is. N plus 2 also the same. You cannot comment on n plus 2. You can only say that's an integer. 2n, yes. Since 2 is an even number into any integer will always be even. Therefore, 2n is our answer. Correct answer. 2n will be always even. And 2n plus 1 will be odd again, because it's an even number, plus and 1, that is an odd number, that's an odd. And n square will be depending on what n is, whether n is, if n is even, n square is even, if n is odd, n square is odd. So that also out. Answer is option C. Let's look at the next question now. How many positive integers less than 100 contain digits 4 or 7? Okay. So let's say 100 digit, less than 100 means there are only 2 digits, up to 99 is what we have to check. They are less than 100. So there are only two options. Say when 4 is in the units digit, what all do you have? You have 4, you have 14, you have 24, you have 34, you have 44, you have 54, you have 64, you have 74, you have 84 and 94. These are the numbers. When let's say that 4 is in the tens digit. When 4 is in the tens digit, you have only 40, 42, 44. 44 has already been counted when 4 is in the units digit. So let's eliminate this because we do not want to count the same number twice. So 46, 48. And let's see when 7 is in the units digit. 7 is in the units digit. It comes out to be 7. When 7 is in the units digits, you will not have any of this because they will all be odd. So you don't need to check for 7 being in the units digit. 7 being in the tens digit, you have 70, you have 72, you have 74, but it is already counted when 4 is in the units digit. So remove the double counting. To remove the double counting, we remove it here. 76 and 78. How many positive integers less than 100 contain 4 or 7? It is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 with the units digit. You have 1, 2, 3, 4 with the 4 being in the tens digit, and you have 1, 2, 3, 4 with 7 being in the tens digit, 4. So adding these all up, you will have 10 plus 4 plus 4, that is 18, that is option C. Let's look at the next question now. The set of prime factors of integer y has one more element than the set of prime factors of 84. What is the least possible value of y? Okay, so 84 is what? 84 is 21 into 4, which is equals to 2 into 2. 4 is 2 into 2 and 21 is 3 into 7. So it's equals to 2 square into 3 into 7. So now they're saying there's an integer y which has one more element in the prime factors, in the set of its prime factors. The prime factors of 84 are what? 2, 3 and 7. So we need the least possible value for y, least possible. Least prime number will be what? 2, 3, 7 are taken. Let's take 5. Let's multiply it. 2 into 3 into 7 into 5, which is equals to 21 into 10, which is 210. Do we have this in the options? Yes, we have it in the options B, 210. The answer is B. Let's look at the next question now. A, B, C and D are integers such that A minus C plus B is even and D plus B minus A is odd. Which of the following expression is always odd? So you have A minus C plus B is even and D plus B minus A is odd. So we need to check which of these expressions will always be odd. So we can add these two. We'll have A minus C plus B plus D plus B minus A. Even plus odd will be what? It will always be odd. And this plus A minus A gets cancelled. You have 2B minus C plus D. This is an odd number, which means since 2B should always be even, so it needs to be adding an odd number in for its sum to be odd. So let's say D minus C is odd. When is that possible? When one is even, one is odd. So if D minus C is odd, then D plus C will also be odd. When the combination is one even and one odd, therefore D plus C, C plus D, that is answer option C. Or you can even come to this conclusion by subtraction. That is, if A minus C plus B is even, you subtract minus D plus B minus A. From here you will have A minus C plus B minus D minus B plus A. So B gets cancelled. You have 2A minus C plus D. This comes out to be odd, since this is odd, and 2A is even. Therefore, C plus D, you can only have even minus odd will be equal to odd. So, C plus D has to be odd. It's the same thing. You can add or subtract. It won't change the answer. Let's look at the next question now. If x and y are integers and xy whole square is positive odd integer, which of the following must be true? So x y square is positive odd integer. So therefore it means that x is odd and y is odd. If either one of these numbers would be even, then definitely their product would have been even. Now the first one says xy is positive. We cannot say that for sure. Xy square is positive, but y can still be negative. Y can be negative or positive. So therefore you cannot say for sure. Second one, xy is odd. Yes, because x is odd and y is odd, product of two odd numbers will again be odd. We've already seen that if one of them is even, the product xy square would have been even, and odd into odd will again give you odd. So yes, x plus y is even. Yes, since we know that x is odd and y is odd, the sum of odd plus odd is always going to be equals to even. So yes, statement 3 is also true. So statement 2 and 3, that is answer is option E. Let's look at the next question. The greatest common factor of 16 and the positive integer n is 4, and the greatest common factor of n and 45 is 3. Which of the following could be the greatest common factor of n and 210? So it's saying the greatest common factor of 16 and n is 4. So therefore n has 4, but it doesn't have 8 and 16. No 8 and 16. N has 4 but no 8 and 16. And the GCF of n and 45 is 3. Therefore n has 3, but what it doesn't have is, what else does 45 have? It doesn't have 9, it doesn't have 5. These are not in n. And you want the what will be the greatest common factor of n and 210. So n will have 3, n will have 4, 210 is nothing but 3 into 7 into 2 into 5. N has 4 but 210 doesn't have 4, it only has 2. So let's take 2. So either it can be 6, or we can say that n has 3, 210 has 3, and n has 2, so does 210, 210 has 2, and we can also say that, we may say that n is can possibly have 7 as well. So there you have 6 into 7, 42. Either 6 or 42 is the greatest common factor of n on 210, whether depending whether it is including 7 or not. Of the given options, we do not have 6 in our options, but we do have 42 in our options. So therefore answer is 42, option D. So the following, it says what could be the greatest factor. It doesn't say it must be. So could be answers are questions are answered like this. Move on to the next question. How many zeros does 100 factorial end with? Okay, so this question is asking us how many zeros does a number end with. For a number to end with zeros, it needs to be multiples of 10. Multiples of 10. So you can check the number of multiples of 10 by seeing how many multiples of 10 is nothing but 5 into 2. How many multiples of 5 are there? Or if you say that then there is 100 multiples of 10, that becomes 100 is also a multiple of 10. Then you will check for 25 when it is 100, that is 25 into 4 will be 100. And when it is 1000, so on, you will have 125 into 8 will be 1000. So you will check for 5s, the number of 5s. And how will you check for the number of 5s? In 100 factorial, how many number of 5s, that is 1 into, this is 1 into 3 into 4 into 5 into so on up till 100. So you will check how many 5s will come by dividing 100 by 5. Now you want to also check for 25, that is 1 into 2 into so on, there's 25, and then you will have 25 2s are 50, and then you will have 100. So to check how many 25s you have, you will have to divide the 100 by 25. 125. 125 is greater than 100, so we will not be checking for 125. So for checking for number of 5s, you divide 100 by 5 and you add the number of 25s. So these will give you the number of zeros that will come, because for 25 there will come 2 zeros, that is it will come 25 into 4, that is 100, but it is already once counted. When you are counting the number of multiples of 5, 25 is already counted once, but here it is giving us 2 zeros, therefore we will add it one more time, we will count it one more time. So therefore we will count the number of 5 once and number of 25 also once, instead of counting it for twice. Hope that was clear. So 100 by 5 is nothing but 20, and 25 by 100 by 25 is nothing but 4. So in total there are 24 5s, 24 zeros that 100 factorial will end with. I hope this concept was clear. Answer is option B, 24. If you are checking for 5 and if you think why not for 2s, there will be many 2s. The abundance of 2s is a lot, because you have 2 is a smaller number, 1 into 2 into so on up till there. You will obviously have then number of 5s. You will have number of 2s that are less, number of 4s are less than number of 25s. So you don't need to bother and worry about those. So answer is 24. Let's look at the next question now. How many positive integers less than 1000 are multiples of 5 but not of 4 or 7? Okay, so positive integers that are less than 1000, that means they are up to 999 only. Up to these positive integers, you need to check for the multiples of 5. How many multiples of 5 will be? You will obviously have to, like in the previous question, divide by 5 to see how many multiples of 5 are there. It will be equals to 199. 5 ones are 5, 4, 5 nines are 45, 4, 5 nines are 45, and a remainder of 1. We don't need to check the remainder, we only need the number. There are 199 5s from 1 to positive integers that are less than 1000. Collecting all the multiples of 5, but they should not be a multiple of 4. So when you are saying that it should be a multiple of 5 and 4, when you are checking the multiples of 5, you are automatically taking those which are multiples of 5 and 4. So we will have to remove those. Numbers are multiples of 5 into 4, that is 20, in 999 divided by 20 will give us 2 9s are 18, 19, 2 9s are 2 4s are 8, sorry, 2 4s are 8, 9, 2 9s are 18, and then you have a remainder. So you will have 49. 49 20s, the numbers that are both divisible by 5 and 4. And let's check for 7 now. For 5 and 7, it will again be 999, that is a number, divided by 35. You can approximate this by dividing 1000 by 35, that is 5 7s are 5, 200s are 7, 2s are 14, 6, 7 9s are 63, 7 8s are 56, and the remainder. So this will approximately be equals to 28 will be the dividend quotient. So you have 28. But what we are doing is removing the multiples of 5 into 4, removing the multiples of 5 into 7. But here we are also removing multiples of 5 into 4 into 7, we are removing them twice. So to reduce that, to add that back, because it is being subtracted twice, you need to add that back one time. So that will be 999 divided by 5 4s 140. You can approximate it by 1000 divided by 140. That will be 2 7s are 2 50s are 7 7s are 49. So there are 7 numbers. We need to add this back because it's being removed twice. So let's see how we're going to calculate all the multiples. All those are factors of 5 are 199 minus 49 minus 28 plus 7, which comes out to be 199 minus 49 is nothing but 150 minus 28 will give you 14 minus 12 is 12, 122, and then you add 7, you will have 129. So you will have a total of 129 numbers that are positive multiples of 5 but not of 4 or 7. The answer is option D. Those were some questions on the topic of number properties. Hope they were clear. Thanks for watching.